Yeah, so that gives you some sort of background to some of the unique characteristics of nanoparticles. Now what we'll do is look at some of the potential applications. And we'll start looking in agricultural applications. So there's a lot of different things that people are exploring in this area, and I'll just highlight a few examples. So one of the big areas is this development of nanofertilizers or nanopesticides. So, typically we would add fertilizers, to try and provide nutrients to agricultural crops to help them grow and improve the yield and improve their resilience. Or we could add nanopesticides to try and stop bacteria or molds or yeasts or insects from destroying the foods. And there's a potential by making these fertilizers or pesticides very, very small, we can change their efficacy. So we can make them work better, or we can use a smaller amount of them. So we're going to have less pollution in the environment. So for example, when you make particles very small, they can get into the pores of plants. So the big particles can't get inside the plants, but the small particles can get into the plants. And often the nutrients need to get inside the plant, or some of the pathogens of the plant might be inside the cells. And if you have a big particle, it's difficult to get in there. But if you have these nanoparticles, it can get in there and it can kill the bad things, or it can provide nutrients. Or you can functionalize the surface of these nanoparticles so they maybe stick to the plant more strongly, and that prevents them running off into the environment. So people are looking at a lot of things in that area. So I'm just going to show you one example here. This is from Dr. Jason White, who works at the Connecticut Experimental Station for the US government. And he's done a lot of work on the application of nanoparticles to agricultural crops. And this is an example where he compared copper nanoparticles with conventional copper treatments of plants. So what he did is he applied the copper nanoparticles in the conventional treatment, and then he let the plants grow, and then he measured the yield of the plants and the health of the plants. So what he found is if he used the nanoparticles, you got much more growth and got a higher yield than if you use a conventional formulation. So this is an example where using nanotechnology, you could improve yields and resilience of plants and therefore have some benefits by reducing food waste and growing enough crops for everybody. So in my lab, we've been interested in trying to make more sort of environmentally friendly pesticides. And one of the things we've been using is essential oils and other kinds of phytochemicals that you find naturally in plants. So plants have developed these essential oils partially to protect themselves. So they're an oily substance which has got antioxidants and antimicrobials in it. So it can help fight against things like viruses and bacteria and pests that might attack the plant. But these are very oily substances, so you can't just apply them normally. You have to make some kind of aqueous formulation out of them. So what we do is we make nanoemulsions where we have these essential oils in these tiny particles, which are a few hundred nanometers big or smaller. And then we apply them to agricultural crops, or we put them into foods, and we see, can they kill the bacteria? So the other thing you have to be careful of is when you're making these kind of formulations, is you have to make sure you work out how much you need to put in agricultural crops. So this is an experiment we did recently where we made an essential oil nanoemulsion, and we made different concentrations of the formulation, and then we sprayed it onto agricultural crops. And what we found is if you use low concentrations, you don't damage the crop and you can kill the bacteria. But if you use high concentrations, you actually kill the crop. So it's really important to get this right, the balance between antimicrobial efficacy and making sure that you don't reduce the yield of the crops by killing them because you damage the cell walls of the plant. Another area that we don't work on, but some of our colleagues have worked on, is developing nanosensors. So this is trying to develop sensors that you can use. You can either put into the soil or you can put into the plant. And what it will do is it will tell you the health of the plant, and it will tell you things like environmental conditions, so things like the temperature, the humidity, the pH of the soil, the nutrient content, moisture content of the soil. So you're continually collecting detailed information about the agricultural crop. And then you're putting in a big database and you're using things like artificial intelligence to relate the environmental conditions to the yield of the crop or the amount of crop that's damaged. And you can even do sort of like personalized agriculture, where you can just focus on one plant and give it exactly what it needs. So the idea is that you just water the plant when it needs watering and not just randomly, or you apply fertilizers and pesticides exactly where they're needed and when they're needed, rather than just doing it indiscriminately like once a week or something like that. So again, that should lead to bigger yields and less waste, but also less use of things like pesticides and fertilizers. And one of the interesting applications I saw in a talk a couple of years ago is somebody had actually got carbon nanotubes and put them inside the plants, and they could send a signal out about the health of the plant.